Hello from Ohio and welcome. Well folks, it's that time of year again when the trees are decorated and the lights are hung up outside. To celebrate this year, I thought I'd make a fun holiday sign. Let's learn how to do it together, this time on Just Making It with Josh. This fun holiday sign can display a neat little fireplace with crackling fire sound, a shimmering blue background, or play two different songs and light shows. I really like the lighted tree project that I did last year using the individually addressable LEDs and the X-Light software to program them. I also like the office sign I made earlier this year, so I thought I'd combine them into a single project that could easily sit on my desk at the office. Now I get to watch a fun little fireplace while working. This project, it took a while to design and work out all the bugs with the lighting, and there's a fair amount of soldering and electronic parts involved. Overall though, I'm pretty happy with the end result, especially since I was able to mostly make use of parts I had laying around to put it together. The parts list on this one, it's a little bit longer than some of the other projects, but hang in there, we can do it. First off, we'll need a 3D printer and some filament. You can use whatever color you like for the buttons and the body, but I strongly encourage you to use a white filament for the fireplace panel. I went with PLA because it's what I had on hand, but anything here would work really. The brains for this project, well, they're going to be a Raspberry Pi. I happen to have a first version Raspberry Pi B+ I wasn't using at the moment. It's old and slow, but it still gets the job done with an older version of the Falcon player. Powering it is going to require a barrel connector and corresponding cable and power supply. You'll need 5 volts and I went with 2 amps. I'll put a link in the description to the ones I used that will fit the hole in the back of the base. The lights are going to be WS2812B 5 volt individually addressable LEDs. I use ones that are 60 pixels per meter. The LED holder will accommodate strips that are 10 millimeters wide. Again, I'll put a link in the description for these as well that I use that fit. Additionally, you're going to want a logic level shifter. This will convert the 3.3 volt output from the Raspberry Pi to a 5 volt signal that the lights prefer. You could probably get away without this since the distance from the Pi to the lights is short, but I went ahead and used one. You can either use a 74HC245 integrated circuit or a simple level shifter that you can get online. If you want to have sound coming from your device, you'll need to buy a cheap USB sound card. Unfortunately, the way the software powering the show works, you can't use the Pi's built-in audio jack, but a USB sound card can be had for fairly cheap. I'd also recommend getting a cheap USB Wi-Fi adapter. This will make connecting to the Pi much simpler and allow you to upload your shows to it wirelessly as well as change any settings you want in the future. I used a small 8-ohm prop speaker from Adafruit for the audio. I simply wired it to an old 3.5 millimeter headphone jack. Now to start the various shows, you're going to need 4 small buttons. The ones I used were about 6.5 millimeters square. You'll also need some various electronics parts. Plenty of wire, of course, as well as 4 1K ohm resistors, 4 10K ohm resistors, a 470 ohm resistor, and a 470 microfarad capacitor. The last bit of hardware we'll need are 6 3.5M 12 millimeter bolts to attach the top and bottom of the base together. Now on the software side, you're going to want to have a 3D printer slicer to print the parts. You'll also need to get the Falcon Pi player to run your light show on the Raspberry Pi. Now, given the age of my Pi, I went with an older version, but if you've got a newer Pi, definitely use the most recent version of the player. Now, to get the Falcon Pi player on the Raspberry Pi, you'll need to flash it onto a micro SD card. I use Balena Etcher to do this, and I'll have links for all of these in the description. Now, lastly, you're going to want to have some kind of light show creator. I used X-Lights, which I was familiar with from last year's projects. Once you have all your parts, it's time to get printing. But before we do that, please note that none of the products or software companies that I've talked about or mentioned or shown have sponsored any portion of this video. As you can see, there are several pieces that are going to need to be printed on this project. In addition to the main frame and panel, the base consists of two different pieces. There's an internal piece to mount the LEDs on and 4 separate buttons. So make sure you set aside enough time to get everything printed. Setting up the Falcon Pi player and X-Lights can be a little bit involved, I'm not going to lie. So I'm going to give an overview here, but I would highly encourage you to watch some tutorials on both of these in order to get a good feel on how to get them set up properly and how to get the most out of them. But in general, the first thing we'll need to do is download a copy of Falcon Pi Player to your desktop from the GitHub page. Then, using a program like Balena Etcher, you'll want to flash it onto your SD card for the Raspberry Pi. Then, insert it into the Pi and turn the Pi on. When the Pi gets started up, you're going to want to set up a few things. Start by connecting the Pi to your computer using an Ethernet cable, and then log into the Pi. The first thing I suggest doing is set up the Wi-Fi. That way you can connect wirelessly to your Pi. You can then access these settings and other settings from the settings screen. Next, I'd set up your outputs. For this project, you'll be using Pi pixel strings with the WS281X protocol. And you're going to have a starting channel of 1 and 121 pixel count. You will configure the RGB setting for whatever works with your string of lights to get the right colors to display. This can vary from string to string, and I use the testing features to figure it out. You also need to plug your sound card into the USB and then go into the settings and enable the sound option. This will allow you to hook up and use the speaker later on in your project. Next, we can flip over to X-Lights. In X-Lights, you'll need to create a new controller for the project. The controller's vendor should be switched to FPP, and the model should be Pi-Hat. Then, in the layout, you'll need to create a custom model using the custom model feature. Make sure when you create the model that your wiring setup in X-Lights matches the wiring setup you choose when you wire your lights together. So I choose to always have the start of my strings at the bottom, but you can have them alternate between the bottoms and the tops if you like. We're going to create an 11 by 11 spreadsheet here. Then starting in the bottom row, mark your cells starting with 1 going up and then left to right until you mark all 121. Be sure that your custom layout selects the controller you created in the previous step. You're then free to create your own light show that will then be uploaded to your Pi. You probably want 4 separate shows, 1 for each button on the Pi. I went with a Fireplace show with a crackling fireplace as a default background, and then 3 other different shows. But come up with what you like and what you want to see. Next, we'll create a playlist for each of those lights shows in the FPP, each with separate names using the playlist editor in the Falcon Pi player. For each playlist, create an event that will trigger that playlist. Then go into the GPIO setup and attach one of those events to the falling trigger on GPIO pins 7, 11, 13, and 15. That's the 1st, 2nd, 4th, and 5th options in FPP. Once you have each of these playlists created on the Pi, set up the scheduler to run your default show all the time by setting the start date to a day way in the past and the end date to a date far into the future. Then set the start time to all zeros and the end time to 24:00:00. Now you're ready to assemble everything. Once you have all your parts printed, you're going to need to get them sanded down to be painted. I then glued the top part of the base and the frame together, being sure to line up the holes. A little wood putty helped fill in the gap between these 2 parts. Now the parts were then primed and painted. As you can see, I went with a rather festive green. I didn't paint the buttons as I printed them using a red filament, and so I thought it looked okay just the way it was. I then used a little bit of glue to connect both ends of the buttons once they were installed in the top part of the base. Next up was the start of the wiring. First, you'll need to cut 11 strips of the LEDs that are 11 lights in length. This will create an even grid of lights in the display. Once you have all of them cut, simply wire them all up from end to end. I wrapped the wires all the way around the back of the panel, but in hindsight, which is always 20/20, using X-Lights, I could have avoided a lot of the wire length by just wiring them up next to each other, alternating the wiring at the top and the bottom of the panel. In X-Lights, I could have just considered the wiring differently. You should wire them however makes the most sense to you. The one key is to have the first string start in the lower left of the panel to line up with the hole that goes through the frame into the bottom base where all the guts are. Next, I wired up a proto board with all the resistors, the capacitor, the logic level shifter, following the wiring diagram I've included. I then wired up the barrel connector for the power and attached it to the base. I also wired the buttons as well as the small 3.5mm jack. At this point, it's simply a matter of finishing the connections between the LEDs, the proto board, the speaker, the power supply, and the Raspberry Pi. Now for me, this resulted in a bit of a mess of wires, but that could have been avoided had I used shorter pieces of wiring. The bottom base includes a place to mount the Raspberry Pi. Now make sure the SD card is removed from the back of the Pi and place the Pi onto those pins. The SD card slot should face the back and the USB ports should be pointing towards the front. I just secured it in place with a little hot glue over the pins just to make sure the Raspberry Pi wasn't floating around in there. Now I attached the speaker to the base using the sticker it came with. I then placed the switches in place on their mounts, just using a little hot glue to hold them in place. Now I'll simply cram it all gently inside the base. Once all the wiring's in there, secure the top and bottom in place with those 6 screws. Then insert the SD card through the slot in the back into the Raspberry Pi. Now, the lighted panel simply snaps in place. It's a tight fit, just be warned. Now it's time to plug it in and watch your light show. I have really enjoyed having this little project at the office. I find the crackling fire to be a whole lot of fun. This project was inspired by some of my other projects, and I got a lot of fun out of designing this one and building it though. I required quite a bit of soldering, which was a challenge for me, and I like that kind of challenge. And the design itself went through a number of iterations before I found something I actually liked. Overall, I'm pretty happy with it, and my friends at the office also like it. I do hope you enjoyed this video and will give this project a try. A link to this project on Thingiverse is in the video description below. Please leave a comment and subscribe to my channel if you enjoyed this video, and I look forward to seeing you in the next one.